Let's solve x to the fourth is equal to 1 plus the square root of 3 times I. I'm going to multiply 1 plus root 3I by 2 over 2. And the reason I'm going to do that is because I want to get 1/2 and root 3 over 2. But if I was just to multiply by 1/2, I changed my equation. So why don't we multiply by 2 over 2, and then I can factor out the 2 from the top as just 2 times 1/2 plus root 3 over 2I. And I know that this is just cosine of pi over 3 and sine of pi over 3. From here, I know that I can rewrite 1 plus root 3I equals x to the fourth as just x to the fourth equals 2 times cosine pi over 3 plus I sine pi over 3. And then I'm going to take the fourth root of both sides. And I can rewrite cosine pi over 3 and sine pi over 3 as cosine of pi over 3 plus 2 pi k, and then sine of pi over 3 plus 2 pi k. And here we're looking for 4 roots, so I'm going to start with k equals 0, 1, 2, and 3. Okay, so let's start off with k equals 0. Actually, first, before we do that, we're going to use de Moivre's theorem, which says that this exponent is going to come inside and multiplied by the angles. So, in other words, pi over 3 plus 2 pi k is going to multiply by 1/4 to get pi over 12 plus 2 pi k over 4, and then pi over 12 plus 2 pi k over 4. And here, technically, you can, of course, simplify this as pi k over 2, but maybe it's easier to leave it like this because you're going to have to get common denominators anyways with pi over 12. So plug in k equals 0, we get 2 to the 1/4 power times cosine of pi over 12 plus I sine pi over 12. And then k equals 1, we add pi over 12 with 2 pi over 4 to get 7 pi over 12. And k equals 2, we add pi over 12 with 4 pi over 4, which is just 13 pi over 12. And then for k equals 3, add pi over 12 with 6 pi over 4, and that's just 19 pi over 12. So now let's rewrite, let's take those answers and just write them in terms of basically real numbers, no longer sines and cosines. And so these are the answers for x to the fourth is equal to 1 plus root 3 times I.